All right, we're on page 97 in your journal. We're going to be comparing additive and multiplicative relationships. So additive is exactly like it sounds, okay? We're going to add something to x to get y. All right, so words that sound like addition or subtraction, I'll let you copy these down. Pause the video if you need to. So what I mean by ER words are words that end in ER, like faster, slower, shorter, younger, older. Most of the time, if they're not coupled with one of these words, then they mean it's an addition or subtraction relationship. Okay? Multiplicative relationships is exactly what it sounds like. We're either multiplying or we're dividing. So for every y, okay, a number is multiplied by x. So again, here are just a few words. Okay, and when I say groups here, I mean anything that could be talking about groups, sorting or splitting or putting things into bags or combining bags of beads. I mean, it could be anything that is talking about groups. Okay, so I'll pause the video and write these down. All right, so let's look here. We have a rule, so we're going to look at the relationship on the table. All right, we're going to look how x is related to y. How do you get from 1 to 3, from 2 to 4, from 3 to 5, from 4 to 6? So we're seeing that we're adding 2 on x to get to y. So what I want to see on your work is I want to see the rule all the way down on your table, and I want to see the rule written right here. Okay? So when you were in 3rd grade, this is what you learned to do. Just write the rule, okay? And in 6th grade, we're learning that that relationship is called additive. It's an additive relationship. So one new thing in 6th grade is that you're going to take this rule and using this right here, you're going to write your equation. So x plus 2 equals y. So that might be an answer choice. If I put the equals y on the front, this might be an answer choice. I'm still saying x plus 2. I could also switch the order. Instead of x plus 2, I could say 2 plus x. Okay, so all of those are possible, and now we'll add a few more on the next page, okay, and a few more possibilities. So on here, you're finding from x to y, from 1 to 5, from 2 to 10. So most people can look at it and automatically see that the rule is times 5, right? Times 5, 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, and so forth. So times 5, I'm going to write it right up there by my variable, by my independent variable, okay, the first one. So that right there is what I'm going to be looking for in my answer choices, is x times 5. So I could write x times 5 equals y. I could write it algebraically like they love to do. I could say y equals, and I could squish these together with that number first, okay? So these could be written a lot of different ways, but those are 2 examples. Okay, so my rule is times 5, and that relationship, since we're multiplying, is called a multiplicative relationship. And remember, I'm going to go fast, but you can pause it at any point if I write too fast. So now we're going to go to page 99. So we're talking about writing equations from tables, all right? So they're going to give you tables that look like this, and you're going to find the rule, and then you're going to find and write the equation, all right? So we're going to find the relationship, okay, between 2 variables where one variable depends on the other. That sounds just like yesterday with the dependent and independent variable. So it can be represented in a table, okay? They could give you a table like this. Or they could give you an equation, okay, and have you pick a graph or a table that matches it. So let's mark through this usually, okay? Not usually, always. X is the independent variable. And y is the dependent variable. Okay, so the value of y depends on the value of x. So as x changes, so does y. Okay, y is just following x's lead. So that's why you can find rules and patterns on these tables. Okay, so we look at this and we want to find a rule. It's getting smaller, so it's either subtracting or dividing. Okay, and we're talking about whole numbers. Remember, when we get into fractions and decimals, it's a little bit more tricky. So I notice that minus 2 is going to be my rule all the way down. So I'm going to put my rule right here. And on my answer choices, I would look for x minus 2 first. Okay, so x minus 2, it would probably have equals y, or the equals y could come first, and they would have x minus 2. So if that's not there, at this point, if x minus 2 is not an answer choice, at this point say, okay, well maybe they weren't reading from left to right. Maybe they were doing something to y to get to x. So the opposite of negative 2 is plus 2. So 10 plus 2 is 12. 9 plus 2 is 11. So you could look on your answer choices for y plus 2, right? Y plus 2 equals x. So that's an option 2. So right here we have, if I'm looking at this right here, excuse me, if we're looking at this relationship, we have 1 times 2 equals 2, 2 times 2 equals 4, 3 times 2 equals 6, 4 times 2 equals 8. So we notice that our is a multiplicative pattern. It's a multiplicative rule, and we're looking for x times 2 or 2 times x in our answer choices. So 2 times x, they usually like to squish them together and make it look like algebra. Or we could put the equals y on the front and say 2 times x. So if that answer choice is not there, you're going to say, all right, well maybe they weren't trying to read from left to right. Maybe we're looking at what we can do to y to get to x. Okay, so they use their fact families. The opposite of multiplying by 2 is dividing by 2. So y divided by 2, that's the second option that you might look for. Y divided by 2 is going to equal the x. So in this equation, y is the total, right? It's the larger number. And in this equation, y is the total. So it stays as the total. So if we look at this one, we have divided by 5, all the way down. That's our rule, so divided by 5. So first I would look for x divided by 5 equals y. Now if that's not an option, my other option would be, the opposite of dividing by 5 would be multiplying by 5, right? So my second option would be 5 times y equals x. But what if that wasn't there either? The only other option is multiplying by a fraction. So this kind of looks like a fraction, right? So if I put a 1 right here, right? 1 times x, that wouldn't change anything, right? So if I put a 1 on top, divided by 5, and then multiplied it by x, that is the same thing as this, okay? So dividing by 5 and multiplying by 1/5 is going to get me the same answer. Okay, so I think on the back of the first page, number 3, keep that in mind, okay? If you're putting division here and you can't find something that looks correct, think about multiplying by 1/5 gets you the same answer as dividing by 5. All right, so on this one, Marty earns $8.50 for 1 hour working at the snow cone stand. He wants to earn $34.36 for a new video game. How many hours does he need to work? So this is the total that we want to earn. Okay, so if our instincts are telling us to divide, then it's going to be a multiplication equation. All right, so if we were to set up a table, we're talking about hours, and remember, time is always the independent variable. That's why I put it first, okay? So hours and then money. So right here it says 1 hour, I make $8.50. So if I continue that, 2 hours, I make $17. 3 hours, I make $25.50. 4 hours, and I'm just adding $8.50 each time. All right? But notice, remember, our instinct was to divide. So I'm not thinking addition is going to be our equation right here. So 4 hours would be $34, and 5 hours, would be $42.50. So I need to find what relationship between X and Y. So I'm going from 1 to 850. And I'm thinking this sounds like groups. So 1 hour is this, 2 hours this. So per hour, right? Per hour, I'm getting $8.50. So I'm thinking this is a multiplicative relationship. So 1 times something would be 850. Well, it's times 850. So 2 times 850 would in fact be 17. 3 times 850 would in fact be 2550. So if I go up here and I write my times 850 equals y, there's my inequality. There's my equation. So I already have y equals, so I just need to write this algebraically. So I'm going to write it just like that. All right, so let's do one on the back. So on your homework, I want to see your rule. Whatever you find the rule is to get from this side to this side. And then I want to see it written beside this variable, because that's going to help you. That's going to help you figure out what your answer choice is. All right, that's true. So I'm seeing that 950 it's getting smaller, it's getting smaller, it's getting smaller. It doesn't look like division. I could try dividing these, but I don't think that that's going to work. So I'm thinking it's subtracting. So I'm going to subtract these two to find the difference between them so I can see what to subtract from 950. Okay, so let's see, 5. So I get $1.75. So I need to make sure it works one more time. So I subtract. Yes, it works one more time. My difference on both of these sets of numbers is $1.75. So I'm going to subtract $1.75. So I'm thinking this is the money I have at the beginning of the day. This is the money after riding the train. I'm thinking that the train costs $1.75. Okay, so that could be a question as well. But now I'm looking and I'm going to put my minus 175 up here by D. Okay, by this first variable. So I'm looking for D minus 175. If that's not there, I can go over and do fact families and find W plus 175. But I'm going to look for D minus 175. D minus 175. Nope. D minus, no. D minus 175. No. D minus 175. Okay, there it is right there. Okay, so on your homework, I want to see these right here, all of these strategies that I taught you.